So I hate to break it to you all, but you know you're truly a geek if you're presented with the choice of should I have lunch or should I go to a talk about cybersecurity, and you pick the talk. Just saying. You're in the right room. This is the best one. Come on in. Come on in. Go ahead and reduce the noise. Good morning, Tech Days. Today we're going to tell the entirety of the cybersecurity story at Microsoft, and we're going to do it in 45 minutes. So we may have to abridge some things, for the sake of expediency, but that really is our goal. I want to make sure that everyone understands our worldview, because if you understand how we think about things, suddenly the decisions we made and the priorities we make in our products start to make a lot more sense. So that's my objective. I really want you to understand what we're thinking and where we're investing so that if you're using our product stack, you can be prepared for what's likely to come. Now, when we talk about security, obviously it's been really, really important lately. Lots of things going on in the news that are, particularly in the U.S., right? You may have heard about the Equifax breach, which is apparently still happening. Now people are redirecting you to a mock flash update page that kind of keep rubbing salt in that wound. It's a really big problem. And it's a problem that's different from the one that we faced just a few years ago. When we look at the differences in what we see in malware today, in the past we would see a particular file that was written out, monolithic malware, and now we see attackers using very different techniques, a lot more living off the land. There's a lot less malware actually installed. In fact, the majority of malicious activity happening on endpoint devices is happening using tools that are already there. Once they establish a foothold, they stop running malware and they start running the stuff you've already installed. Because we have implemented so many new controls, such as enforcement of code signing, application whitelisting that continues to get easier, the adversary has to go and use trusted actions to get things done. Fileless attacks are becoming the new normal. So I want to kind of go through a few of the scenarios that we've seen to start to think through the adversary activity, because the big pivot is not to think about what it is that each adversary is doing specifically, but instead to look for patterns. What's everyone doing and how can I defend against that? So I'm going to take an example from what we saw in one recent attack vector from what we call an APT, or an advanced persistent threat. A nation-state attacker is another way to refer to it. What are some of the techniques that they used? Well, they used a UAC bypass, and they did this using Event Viewer. And the real thing about UAC bypass is not so much that they want to bypass UAC. UAC, incidentally, is not a security boundary, so if you're running people with local admin rights, even if you have UAC turned on, don't think of that as a security boundary. The real goal here is to stay hidden. Because in a process object in Windows, we keep track of who your parent process is. Not your grandparents or great-grandparents or anything there. So if your parent appears to be Event Viewer, you seem safe because it's a Windows binary. When actually, you were the parent of someone else who went through Event Viewer and used that to hide themselves. So they used a UAC bypass to do a better job of staying hidden. Once they got onto the device, they used a PS attack kit, which in essence downgrades PowerShell. For compatibility reasons, you can say, hey, PowerShell fly with all of your great logging. Let me go ahead and turn that off and go back to PowerShell 2, which didn't have any logging, so I disrupt your ability to log that. Incidentally, that emits an event ID 400, so you can detect that's going on. And then once they get on there, they of course use Mimikatz, because as my very good friend Jessica points out, Jessica Payne, who I'm borrowing this material from with her permission, because she's the one that did a lot of this research and investigation, she says everyone uses Mimikatz to go and harvest all of the identities that are living on the device. Once they get on there, they would also clear the event logs. Note that clearing the event logs, in addition to covering your tracks, emits event ID 1102, something you as a defender may want to monitor for. And then finally, they used PSExec to move laterally, using the credentials they harvested as well as the interactive user account. So you can start to see some of the techniques that they used to gain some initial ground. Let's look at another attacker. This one is MISFOX. And everyone ignored this one for the longest time. They really considered it to be commodity malware. But what we want to look at is what are the techniques that they used. Again, they used a pre-designed kit, PowerShell Empire, which utilized scheduled tasks and services to, get different accesses on the system. They also used the PS attack to do PowerShell downgrades. As a reminder, that emits event ID 400, so you can go and detect that. They were using Reg Server 32, leveraging a bug that existed in that because we used to take an SCT file from a URL over the internet. You could actually point it to an arbitrary bit of Win32 code somewhere on the internet. It was a defect, was lovingly referred to as squibbly-doo, that we subsequently went and fixed. And then, of course, because everyone uses Mimikatz, they used Mimikatz, and finally, they went and cleared the event logs. The interesting thing about Mimikatz is that it didn't always do it necessarily cleanly. Let's look at a final attack scenario. Ransomware, right? In this case, NotPetya. How did they get onto the device? Well, they used the Eternal Blue compromise, which is something that still is remarkable to me, is we patched it in March, and I understand that not everyone patches things straight away. But when in May, when the first attack started coming out, if you saw that happen and didn't immediately start patching, well, that's very odd behavior. How many warnings do you need that patching is a good idea? So they leveraged that to move around the network, and they also would use PSExec and WMI to move around the network using standard lateral traversal techniques to get onto other devices. They, of course, because everyone uses Mimikatz, use Mimikatz to grab credentials and harvest them and move around. And naturally, they cleared the event logs, emitting event ID 1102. And then they registered the new scheduled task, which is what actually did the encryption of, in essence, the file table that gave you the ability to see everything and made the device inaccessible. And so you start to notice a lot of similarities here. And when we think about how do we build a defense against that, we need to think holistically, because a defended network is one that we have to build. We can't buy it. And this is something that I can't emphasize strongly enough. It's certainly something that we're committed to. You cannot stroke a check and buy a product, no matter how good their salespeople are, no matter how nice their suits are, and no matter how shiny their teeth are. You cannot write a check and become secure. You need to do work. Because we typically look at a flat network design in most of our customers. You can get from any device to any other device to do anything you want to, which means if you want to go after a goal, you can go directly to it. So when we look, for example, at one of the advanced persistent threat adversaries that we investigate, on average, on their path from initial entry point to domain admin and compromise of the entire environment, they touch 3 devices because they can move around so quickly. So what we want to do is instead start to segment the network and put in additional controls, to put in things like multi-factor authentication to enforce that I'm getting on there, and to start to put in device constraints, conditional access to ensure that I'm coming from some place with a known root of trust. If I'm doing server admin, going through a jump server hub so that my administration all comes from the same IP range and not from arbitrary devices on the network. Each of those controls is not only a protective control, but an additional detective control that I can monitor. looking at it holistically, really 4 primary bullets that we want to think about in terms of how do we defend ourselves against the adversaries of various type that exist out in the world. Part of it is we see over and over and over again, credential hygiene. I need to make sure that I am partitioning off my privileged credentials, and we'll go into all kinds of details on that. I want to segment my network, right? We see this in some extreme cases within financial services with initiatives that's typically referred to as compartmentalization. In essence, building a completely segregated and isolated portion. Now, the word of warning that I will give there is that you can do too much of that. The key is to get the right amount. If you are going to build a segregation, a dividing line between two things, make sure that dividing line is one that you are willing to vigorously defend. Because all too often I see, I'm going to build this whole different domain, this whole different forest, and here's 2 and they're completely separate. Step 1. Step 2, let's build a two-way trust between them and have this transitive mutual trust. Right, so in essence, let's build a 13-foot tall brick wall, step 1. Step 2, let's get a wrecking ball and knock a few holes in it. If you're going to do that, my recommendation is don't bother building the wall in the first place. So have appropriate network segmentation. Pursue relentlessly the principle of least privilege instead of the principle of most convenience. Give people everything they need to do their job and no more. And finally, do very targeted monitoring. I can't tell you how many customers I work with where they have vast amounts of data that they're collecting in their security event monitoring systems, or SIEMs, that they do little to nothing with because it's so much data. Look specifically at certain events. We talked about a few of the specific event IDs that can be indicative there. Get really smart about looking at what are you going to choose to monitor and continue to automate and get better. So let's go into more depth, and the taxonomy I want to use to facilitate this conversation is a taxonomy we call the tier model. And the tier model is just a way for us to divide our different assets up and think through them. Begins with tier 0, which is the identity plane. That's where I define who I am and give controlled access to all of my resources. Tier 1 is my servers and services. That is where I house my business data, my databases, my middleware services, and where all of that lives. And tier 2 is the endpoint. That's where I do my work. And that taxonomy is helpful because I can think about the average value of an identity, particularly a privileged identity, in each tier. If I'm able to gain all of the tier 2 identities, I can control every single device, I can see everything you have that's of value. Similarly, if I have all of tier 1, I can see all of your digital assets that are of value. Tier 1 is generally more valuable for 2 reasons. Number 1, there's typically fewer tier 1 devices. Most organizations have more workstations than servers. Not all, but most. Number 2 is if you're an adversary, you're human, and like us, you're probably pretty lazy. Which would you rather attack? SQL Server or a Delphi application written in 1998? Probably SQL Server. So you'll go after tier 1 first if you can get it. A single tier 0 identity, any one of them that has privileged access, is the security equivalent of all of tier 1 and all of tier 0. So when you think defenses, tier 0, obviously very important. That's the master key that unlocks everything. And the typical attack pattern we see for someone who's going after domain level compromise is get onto a device, start moving around the network, grabbing and harvesting additional identities until eventually you get the big win, you get the domain admin credentials, and you own the entire environment. So we want to make sure we have defenses that really protect against that. So as we think through these tiers, there are some things that I'll suggest you should be doing regardless of what tier the device is on. The first one is, and hopefully we've learned this, patch aggressively. The typical timelines that we see of quarterly patches, biannual patches, do not work in today's world. right? I know that the Australian government is pushing, I believe, a 2-day cycle to get patches deployed. We typically recommend getting somewhere between 4 and 7 as being aspirational for most organizations. The faster you can go, the better. And that applies to numerous things, including, as we saw with some of the recent attacks, Equifax is one of them, that was based on them not patching an issue in Adobe Struts, which would have caused them to recompile and push through. So they would have had to explore their whole DevOps model to be able to more quickly put in code-based patches and put them through to production. We want to apply baseline security policies, and this is something that we are seeing more and more as a recommendation. Microsoft has gotten very, very serious about publishing security baselines for all of our platforms as soon as possible. We've already published a draft that we're now working on finalizing of a security baseline for the fall Creators Update of Windows 10 that you can start using today. That will give you all the recommended guidance of what actually adds security value. And it's also going to make you look more like a known state. So we know and understand that configuration that you're building on. We should be using multi-factor authentication absolutely everywhere. We saw that with a recent compromise that was in the news for a consulting firm in the US where they didn't turn on multi-factor. They had easily guessable passwords and someone just went in and guessed them. So more and more we're seeing the impact of the fact that the ability for adversaries to crack passwords is much better than the ability of our users to remember them. So moving towards that model is something that we're building into our products and we're driving into our core messaging. Really, really important to move there. It's important to separate out administrative accounts. I should not be doing work logged in as me, checking my email, and then immediately going and logging into a server with the exact same identity and having privileged access. I want to divide those two things out. And I also want to make sure that I'm randomizing the local admin password on all of my devices. This is something that we felt was important for a while, but we didn't actually build anything to solve that. And finally, it took one of the consultants that we had working here actually in Europe, not in Holland. He just built one, and we sat down and ran it through the whole secure development lifecycle process and released it and said, here it is, world, it's free, that you can use to generate these random local admin passwords. These practices are important across all devices. Let's dig a little bit into Tier 0. What are some of the defenses that we're seeing using in Tier 0? The first one is I should be doing my work from a hardened workstation. I need to establish a chain of trust that extends from the device all the way to the asset. Because what I want to mitigate against is if I'm coming from a device that is exposing itself to potential adversaries via checking email, browsing the web, or doing other less safe tasks, the adversary gets on that device, then they can either grab my credentials directly or control the device I'm working on to gain control of that service. So I want to have a hardened workstation that's going to really dial up the knobs, to do application whitelisting that says you don't get to run web browsers, they're not on the whitelist. You don't get to run productivity apps, you don't get to run anything. We're going to explicitly say these are the only things that should run. They're the tools that you use to do your administration and nothing else. If what you are administering is a cloud service, we want to proxy the web browser because one of the conflicts we have is you can't very well block the web browser if you're trying to administer a web service, unless you can do everything with PowerShell. So I need to do a whitelist of the URLs I'm going to allow myself to go to put in those protections so I'm locking things down and we can be sure that, hey, the only thing that's running on this device are things that I trust to do my administration. Now, one of the big objections that we historically heard was, hey, us administrators, we're getting kind of old. And these devices are heavy. Yes, they're lighter than they used to be. I remember having the old workstation model machines, right, that would weigh, the power brick itself would be 15 pounds, or a little bit better, but piling multiple devices in your backpack really just doesn't work, either from a user acceptance standpoint or from a cost standpoint. If I suddenly have to buy thousands of additional laptops, that makes me grumpy. So the design that we are actively building right now, and we announced this at Microsoft Ignite, is one that uses what I call the Launchpad architecture. So on Client Hyper-V, you can define a root VM, right, that will in essence whitelist to say the only things this is going to launch are going to be child VMs or remote VMs. And then my child devices, I can have locally on the device my productivity virtual machine, which is a child, right? Because again, the root has control over the child, but the child doesn't have control over the root. That boundary between virtual machines is truly a security boundary in Windows. And it's a security boundary that is a particularly good security boundary because if you think about it, if we cannot defend the boundary between two virtual machines on Windows, then Microsoft Azure is not a viable product for us. Now you may have heard, but it seems like we're kind of interested in doing this Azure thing. This might be a bit important to us. So it's very important that that works. So we can leverage that and say I can have two machines that are side by side that are of different levels of trust as long as the parent, in this case the launchpad, is trusted to the highest level to provide that level of isolation. Now, one of the things that I do see from time to time is folks who will say, well, I don't want to do anything on my devices. That's kind of a pain. I'm going to go through a jump server and have a jump server paw. Now, I like the idea of jump servers, but not as paws. And I think that's the semantical thing is they're not your paw. Concentrating through a jump server is the architecture that we're building for Project Honolulu. We stand behind that. You can then tightly constrain the management protocols from the jump server farm to the assets and have a great monitoring point for doing that. However, they're not your paw because if you compromise the workstation that's talking to the jump server, you can compromise the jump server. Now, lots of times people didn't believe me when I said that, so I went ahead and wrote the compromise. Right, so here I am connected to a jump server. I'm over remote desktop, and if I were a bad guy, right, this bad guy happened to give me a nice window that has a pwn button on it. So security advice number 101, if a button appears on your desktop that says pwn, do not click the button. But let's watch what I can do if I'm the adversary. Now the adversary obviously is going to remain hidden, but let me just click the button and then hands off the keyboard. He can send keystrokes directly to the console on my behalf to go ahead and create a user for themselves, add themselves to the local admin group, dump data, do whatever they want to, clean up after themselves, do whatever they want. Now many people then think, oh, well, I'm going to see them doing that, so I'll know that that happened. Well, let me posit the next logical enhancement to this attack. I can take a screenshot. There's a screenshot API in Windows, and open up a new window, set the screenshot as the background, and now it just looks like your connection to the remote server froze for a minute. Then when you finish doing your dirty work and cleaning up, you remove the window, and now you're back to normal. Now, if you're connected to a remote server and it freezes up for a minute, does that appear abnormal to you? Most people think it would be abnormal if it never froze up. Trivially easy, and if you look, I did this in, this is the actual code, 262 lines of code that I could optimize even further. It didn't even take much work. If I, as a very amateur offensive researcher, can crack this model, think about what a real pro could do. So we want to think about jump servers for what they are good for. We just don't want to call them a paw. Have a hardened workstation that limits what you're allowed to run. It's just a matter of doing it. It's a lot like if you think back to rock stars in the 1980s, right? In the 1980s, rock stars would just go around and do whatever they wanted, and once a month they would get a shot of penicillin, and that would make everything better. That doesn't work anymore. Just like in the metaphor, today you can die if you do that. So implement privileged access workstations. Another recommended architecture is what we call the red forest architecture, a way of further isolating and putting in technical controls. Because what's the hardest part about constraining a domain admin? A domain admin has local admin rights on every single workstation in the environment by default. You get it all automatically. How do you control them? Well, you could remove them from the local admins group via group policy. Turns out domain admins also control group policy. So you can't really put in effective controls. In the red forest architecture, we say build a separate administrative forest with a one-way trust and place my hardened admin workstations in the separate forest. It also gives me a place to put in some dedicated tier 0 services. So an architecture that's very useful for actually putting in constraints, because in the red forest I can be a standard user. And I enforce the fact that you must log into one of these workstations, because if I try to log into something in the production domain, it will say, I don't know who you are. I can't log you in. No credentials generated. I can actually get technical enforcement. Implementing monitoring of authentication traffic. Right? Advanced Threat Analytics is the product that we have out in the market that looks at what is the login behavior that's happening and how can I apply sophisticated rules to understand what of that is normal. Now, some things are inherently bad all of the time, right? Other things are bad based on context. You know, if one, typically in a given day you log into 3 different systems and all of a sudden one day you log into 1,300 systems, that's an anomaly that we can flag on, right? And that would prevent things like the Edward Snowden incident where all of a sudden one day he connected to all of the things and downloaded all of the stuff. That abnormal activity can be detected. Caveat, if the enemy is already inside and moving around, their existing behavior will baseline as normal. Right? So there are some limitations in what we can detect based on how clean the environment is. We want to work to minimize the attack surface. This is something that a lot of people don't think about. Tier 0 is not just my human domain administrators. If I have managed antivirus running on my domain controllers, it is taking commands from someone else. So the administrator of my antivirus solution is a domain admin equivalent. Certainly worth looking into if someone like, say, Kaspersky of recent news is someone who is providing you with antivirus services and you are a U.S. government federation, which is why you've seen that the U.S. government has moved to remove that. If on your domain controllers you are using shared storage, whoever administers the shared storage is a domain admin equivalent. Virtualization fabric, the virtualization admin, domain admin equivalent. Likewise, flip the inverse. If I have a service running on another device that is a member of the domain admins group, everyone who has privilege on that device is a domain admin equivalent. Measuring how big your tier 0 is and making it smaller, as small as you possibly can, is really, really critical. The worst case that I've seen so far is an organization that had a service running on every single endpoint in the organization where that service was running as domain admin. So literally, you compromise any device and you get the rest for free. So we'll certainly want to avoid that. Make it as small as possible and then look to continue to minimize your exposure by modernizing the roles and the delegation. Particularly in the case where if you have a managed service provider, do you really want to hand over the domain admin keys to your managed service provider? They may have to do some tasks, but can I define a GIA or just enough admin endpoint? For those of you who are unfamiliar, we'll see a quick demo of this later. GIA allows you to define a PowerShell remoting endpoint that whitelists the commandlets and functions you're allowed to execute. So if I need to allow you to administer DNS, I can expose everything in the DNS commandlet framework, and nothing else will be allowed to run. It's whitelisting for scripts. So now I can give you permission to do something without opening everything up. Do you have a quick question? Authentication policies, authentication silos can certainly be helpful for constraining where people sign in on different devices. I see that used more frequently in Tier 1 than Tier 0, because Tier 0, our recommendation would be red forest if we can. But if I can't do that, then I would look at auth policies and auth policy silos to make sure that my domain admins are only logging into a PAW. Right, and we're also looking at how do we build conditional access for PAWs so we can continue to further enhance that, which becomes easier once we've standardized and shipped something. So definitely, great question. Let's actually dig into tier 1 and move through that line there, right? Guess what? We need hardened workstations again, right? If I'm going to be administering a server, I don't want to be doing it from a random location. Then I want to start to constrain the administration I'm able to do by time, right? And rather than the old model, we call it JIT, or just-in-time administration. Because the old model would say, no matter where I go, I'm going to have all of my privileges with me. So if I have the ability to administer 4 servers, I will have those privileges carried with me all of the time. So in this case, I'm moving through the course of my day. I start my day on my productivity, doing my productivity work. Then I log into System 1, do my work there. Then I'm back to productivity work. Then I log into System 4, and I'm back to productivity work, and I move through my day. So if someone compromises the productivity workstation, they get all 4 server credentials. Someone compromises system number 1, that server, they get all 4 of the credentials. They compromise system 4, they get all 4 of the credentials. We have to assume that something is going to be compromised, that I'm going to have some server sitting somewhere that has a hard-coded dependency on Java 1.6 update 22, and that therefore is higher risk. And if I can then grab all of the other credentials when I'm there, that's a problem for us. What just-in-time administration allows us to do is say, hey, I'm going to request access to join a membership of this group, and it gets added just in time. So when I'm on server 1, I only have server 1 with me. Then when I'm done with that maintenance cycle, my membership expires. And then later on, when I need to get onto System 4, it's the same thing. I request access. I say I need to get on here for 1 hour. When the hour is up, it goes away. Particularly if I'm on Server 2016, Server 2016 will actually time your Kerberos expiration times to the duration of your shortest group membership. So you'll have to go and refresh it and get a new Kerb token that will lose that membership. Right? So it's built in from an enablement standpoint into Identity Manager's PAM module. We also mirror that in the cloud with PIM. I don't know why we called it 2 separate things. Please don't ask me to explain our marketing department. I don't understand them. But Server 2016 adds specific functionality to further support this approach to just-in-time administration. So I want to do privilege vaulting. I also want to continue to constrain by capability. What am I allowed to do by standing up GIA endpoints where it makes sense? If I'm giving you full admin permission on the box that you don't actually need, I'd rather constrain it. Because if I look at, hey, you're an admin, you can manage the storage on the device, you can manage Hyper-V on the device, and you can do some SQL stuff. Well, if I'm just a database operator, I don't need to manage Hyper-V on the device. I don't need all of that. I just need to run a backup so I can expose the command to run the backup. And if I'm the SQL admin, I may be able to run the backup and also execute some SQL code and do some additional work. I can whitelist those things without allowing all of the other things that come with it, unless I need to do both tasks. So I can expose specific endpoints that I can connect to that constrain what I'm able to do. Going through jump servers, as mentioned before, adds some benefit in terms of a concentration. So I have a monitoring point where I can see activity rather than, hey, random activity is coming to my server. I can start to spot anomalous things now. If normally I'm only connecting on this protocol to this server from this group of jump servers, as soon as I'm trying to connect there using that protocol from an arbitrary endpoint, that endpoint becomes suspicious. And I can start to look at that. That's the design that we're building into Project Honolulu, which was announced earlier this year. And then I want to continue to build out those role definitions, particularly if the way you do server administrations is, hey, congratulations, you're an administrator. Welcome to the all server admins group. And you have administrative rights on every single server that there is. To instead be able to say, I want to have the rights to this particular set of services that have the equivalent security value. In the absence of that, I would still prefer to go device by device, right? But it's nice if I can say if I have a clustered set of SQL servers that all basically house copies of the same data, but it may span 50 different devices, it would be nice to have one role that covered all of them. But it would if I have to choose between all of the servers and 50 different servers, I'll pick the 50 different servers from a security standpoint. So further refining my role definitions to harden up tier 1. Now let's make our way all the way down to the endpoint. And that begins with removing admin rights. Right? If I have local admin rights, then it's really difficult to protect that. And this is something we've actually seen, like historically, the hardest audience to do that to was, guess who? Developers. You try taking away admin rights from a developer, right? And they will scream and cry and yell and call you names and be very rude. But if you notice what happened at CCleaner, if anyone caught that exercise, that was actually a compromise all the way into the supply chain. They got onto a developer's workstation and injected the malicious code during the development lifecycle, it seems, because it was then compiled and digitally signed with a certificate from that company. And that's actually a threat that we're very much aware of. So within Microsoft, we're highly aware of that, because what happens if you can't get through the defenses of a product like Office 365 or Azure, right? If we've done our job, they're hard to get through. How do you get through? Find random developer on the team, inject the malicious code into the source code directly, wait for it to publish, and then compromise the exploit, the vulnerability that you wrote. So our developers work with a variant of PAW that we call SDWs, or Secure Developer Workstations, that don't have admin rights, that use application whitelisting. And we really do chase out like a pathway between, hey, writing the code and checking it in. You may have to go off to a virtual machine somewhere that has admin rights to do some testing or use some tools, but that should not have write access back into the source tree. We need to have a clean path from developer keyboard to publication, and have admin rights only exist on the side in a way that can only consume from and read from that chain. Now, removing admin rights can be hard. There are a few things that we need to do. We need to take the applications that are broken and we need to fix them. And fix them not just by granting them admin rights using a tool. That is an approach that I don't like, because think about what that means from a security perspective. I'm moving from a world, right, because people are never admins to computers. Our programs are admins. Programs that we start, but programs are the only thing that run with admin privilege. So we're moving from a world in which everything I run runs as local admin to a world in which only my oldest and worst applications run as local admin. Is that really that much better? Because I've only filtered out the new good stuff. And I'm still giving admin rights to my most vulnerable software. So I would rather understand what that dependency is. We have tools. My friend Aaron Margosis writes a tool called Lua Buglight that's very much worth investigating for figuring out why something needs admin. I need to make sure that I'm actually effectively distributing software. Right? A lot of people use local admin rights as a crowdsourced way of doing software distribution. Right? If they need software, I need to take responsibility for packaging it and sending it to them. And that means I'm probably going to need to get better at app portfolio management, because if I, as the worst customer I've worked with in terms of proliferation discovered, if I'm trying to manage 225,000 unique applications, that's hard to do if I need to package all of them continuously. If I get that number down to what's truly core to our business, it becomes more manageable. When it comes to fixing, there's actually a lot of things that we're able to fix, right? And for more details here, I would point to both the session we gave at Microsoft Ignite. I talked about securing the endpoint, as well as some of the historical app compat stuff we did back in the Windows 7 days when the initiative first came out. So we can get a lot of stuff fixed to remove those admin rights. We then need to harden the OS. We need to get modern. It's going to be difficult for me to do the same things on Windows 7 as I can do today on Windows 10, right? I need to change my perspective from, hey, once every 5 to 10 years, go through this massive 18-month-long project to update the OS. To instead get a lot more agile to say, hey, I'm actually pretty good at deploying updates because I get to practice it every single month on the second Tuesday of the month. It's something we have a great deal of practice in doing. We need to make it look more like that, because from a risk perspective, The application failure rate moving from Windows XP to Windows 7 averaged 21% in enterprise customers. The application failure rate we see moving from Windows 7 to Windows 10 is just below 2%. So it is an order of magnitude smaller. And from Windows 8 or later, or from current Win 10 builds to more modern ones, it is a fraction of a percent. Now, why the difference for Windows 7? It's because starting with Windows 8.1, we lie about the version of Windows by default. If you asked Windows 8.1 what version of Windows is, it will say, I am Windows 8.0. If you ask Windows 10 what version of Windows it is, it will say, I am Windows 8.0. That is the only difference that accounts for nearly 2% of application failures. Your software is trying to make sure that your OS distribution team is doing their jobs every time they launch. So we need to fix that. And it's not just modernizing the OS, it's modernizing all of the other middleware. I show this slide, and every now and then I still run into folks who've never heard this. Are you aware that Oracle is deprecating support for Java in the browser? Because most people run Java in the browser somewhere, right? So if I don't have a plan to get out from underneath that, that's a problem. So it's all of my middleware, it's my OS. I need to get current across the board. And once I get to that destination, to start enabling new features, right? You know, whether it be enabling multi-factor authentication through Windows Hello, or whether it be, you know, doing application whitelisting with Device Guard. And we'll talk about whitelisting a little bit further in the session. We want to make sure that we're running our software as hardened as possible, following the guidance that we provide in the secure development lifecycle, a process that we developed internally at Microsoft, led by Michael Howard, who still to this day works with customers to teach this. We do not keep this a secret. We give it away to everybody for free because it is so important to the software ecosystem. SDL also works with agile development cycles in addition to the traditional waterfall methods. We also want to retroactively secure software with something we'll talk about in more depth at my talk tomorrow, Windows Defender Exploit Guard, which allows me to put in protection that the developer may have forgotten about, not known about, or that simply didn't exist. So I can harden the defenses of the software that lives on my system, and then move towards application whitelisting. Now, application whitelisting is hard, but this is the next major pivot. The last pivot was moving from everyone's an admin to no one's an admin. This one might be harder. This one is moving from a world in which we trust everything by default and mistrust by exception to instead we mistrust everything by default and we trust only by exception. But that's hard. It's not pragmatic to do it that way. So we've positioned a four-part strategy for getting to application whitelisting. The first one comes alive in the Fall Creators Update, which is cloud control. Basically, if an application has a reputation on Microsoft's security graph, a reputation of, hey, this is good software, it's allowed. Now, you may not want it running, right? Because guess what's going to be on there? World of Warcraft is perfectly trusted software. You may not want your users running it, but it is trusted. The next stage of evolution is something that I refer to as Aaron Locker. It was a technique that we've been working a lot on automation of this, and my friend Aaron does this. And I call it that mostly because Aaron hates the fact that it's called Aaron Locker, so therefore I continue to talk about it in presentations and call it that. But here's the concept. I'm actually going to jump to an illustration of that. Whitelisting the admin writable areas. So it's a path rule using AppLocker. If it's in program files, it's okay. If it's in the Windows directory, it's okay. Now we put in some exclusions because there are some user writable things that live there. So we exclude those and say if it's user writable, we do that. That's part of the scripting work that Aaron's actively working on right now is how do we use, and he's using the sysinternals tools, right, to the access check to determine, hey, what's the permissions on these directories? Let me exclude what's user writable to build that initial list. Then we need to go to the flip side. There are some applications that run from user writable areas that you don't want to block. For example, Microsoft OneDrive runs from the user area. So does Microsoft Teams. So do parts of WebEx. So does the Pepperflash player from Adobe Chrome. right? There's lots of things that you would want to have on that list, so we need to do some discovery. And so that's the work that Aaron has been working on to not only get the fundamentals down, which is an idea that originally came from NATO, was established then by the NSA. They put out a white paper. We're working on automating that, right? We had a session that we talked about at Ignite that I'll refer you to for more details and demonstrations of what that looks like so far. Manage installer is the next step. That is anything laid down by my installer, whether it's System Center Configuration Manager, Altiris. I've even seen it done with Marimba, right? Intune, anything can be approved as your managed installer. If that tool writes it to the disk, it's allowed. So now your control point becomes your software installer, and everything in there is whitelisted. All the way up to explicit control, where you say, on this device, this software runs. That's hard to do in the general case today, but if you run things like point-of-sale systems, ATMs, or anything like kiosks, then explicit control is where you want to go. Finally, think about support. How do I support my end users? This is something that most people don't think about, because typically, if I'm just calling the help desk and my help desk is a member of a group that has privilege everywhere, well, guess what happens? Someone gets on my device, they make it act up, you call the help desk, they hop on, you grab their creds, and boom, now you own all of the other systems in Tier 2 and maybe even Tier 1. Now, that turns out to be relatively hard to stop, so a solution that I'm actively working on building right now, and I'll show you a quick demo, is one that exposes a GIA endpoint. So we can see GIA in action, right? Now to simulate this, I don't actually have a full directory of everything there. I'm just storing my passwords in a registry key that I don't have permission to go and see. But what I'm going to do is I'm going to use a PowerShell remoting endpoint where I've defined a GIA endpoint. I've called it HELPDESK. And from the HELPDESK, I can go and say, show me all the things I'm allowed to do. That's the whitelist. These are the only PowerShell commands that I can execute from this remoting endpoint. So I can from here go and say, yep, give me the password for this. Here's the password, right? Conventional convenient GUIDs, because who doesn't like a good GUID? Then if I can start to enforce rules because I'm running code, right? So rather than giving you access to all of the passwords at once, by having a GIA endpoint, I can constrain it to say, you know what? You only get to have one at a time. Ah, you already have one checked out. You can only have one at a time. The other rule I've been working on implementing is to validate with your existing ticketing system. Don't give someone the admin password to a device that there's no open help desk ticket on. Otherwise, what are you going to do? You're going to come in and you're going to request the password to Satya Nadella, if you're smart. If he doesn't have a help desk ticket open, you shouldn't get it, right? So if I were to then check that in and say, yep, I don't need that password anymore, whoops. Right, check it in, and then I can go and get the password from computer number 2, and I can put in some controls, right? The main point is to make sure that I'm giving one-to-one access and enforcing whatever business rules make sense. So with that whirlwind tour, hopefully you have a better understanding of Microsoft's end-to-end story of how we think about security and how it's materializing in our products. Thank you very much for coming, and hope you enjoy the rest of the show.